Welcome to another Animation Notes tutorial. In this video I will show you how you can use Blender and EEVEE and Animation Notes to create these kinds of effects. I got this idea while I was working on my Sci-Fi laser 3D printer tutorial, which you can of course find here on my channel, along with many more Blender tutorials. Okay, first let's delete everything, get a model in. I'm just going to use the monkey head for the tutorial. For my renderings that you saw on YouTube or Facebook or Instagram, I used the add-on MB Lab and created that female character. But of course this works with any model, and Blender comes with a monkey head, so let's use a monkey head. Okay, I'm also going to add a plane right away and scale it up a little. And this is just so that we see something in our scene here that we can manipulate for where the laser beams should be coming out of. I'm gonna set this to wire. Okay, split the view, go over to EEVEE right away, and you know what? Before I do anything, I'm also gonna set up the lighting and the materials a little. I'm going to duplicate Suzanne, Shift D, then Escape. I forgot to switch on the screencast keys so you can see what I'm doing. And one of them is going to be for animation notes, the other one is the one that's going to be visible. So let's make this one visible, add a subdiv modifier, right click, shade smooth, and then go into material settings, give it a new material, head over to shading quick and the EEVEE view, and to give it this sort of holographic look, I'm just going to take a layer weight, turn this down, pipe that through a color ramp, facing, what does that look like? And then I'm gonna bring those in just to get the outer edges for an emission shader. Set to something like 5. Okay, now we can fine tune this a little. So it looks like this, almost like a toon shader, but with the emission and of course the bloom effect. This looks cool. Okay, let's go back here. I'm just gonna bring this up and make this an animation notes window, and then make another timeline down here. So, first thing we need to do is find the vertices on this Suzanne, the one that's not visible. Well, let me just make it visible. The low poly one. We're going to find the vertices that are close to this plane. Of course, using animation nodes. So we create a new node tree, hit T, then switch off always and switch on these 3. How do we find the vertices that are close to the plane? Well, first we need to get the vertices. So we get a mesh input, and we plug in our low poly Suzanne. And then here we have the vertex locations in a list. Perfect. Now we have to go through each vertex location and see if it's close to the plane, which we do in a loop. So we create a new loop. We need a new iterator, which is a vertex or a vector list. I'm going to call those vertex locations. And then W, create invoke node, and we can plug in the vertex locations. Now inside of the loop, for each vertex, we have to figure out if it's close to the plane or not. So there is a node, you can hit Ctrl A and then look for the node which is called project point on plane. And that gives us the distance here. A plane in 3D is always definable by a point in 3D space and the plane normal. Okay, we have a plane here. How do we get a point on that plane and it's normal? So first we have to look, Control A, we have to get like a plane. What do we have here? We have a convert plane type, which gives us a point on plane and the plane normal. And in here we need a matrix. So we just get the object matrix input of the plane and we're done. And then we get a distance here to this vertex. So this loop goes through each vertex of this monkey head and tells us the distance of that vertex to that plane. So this vertex up here, this one, is going to be further away now from this plane, and these ones down here are going to be closer. And the ones on the bottom of the plane are actually going to have a negative distance. So right away I'm going to take a number math, set to absolute, distance to absolute, because I don't care about negative or positive. I just want to know how far away is the vertex to the plane. And then we can go to Boolean and compare. And we compare if the distance is smaller than, let's say, 0.1, and we get a Boolean. So what can we do with this Boolean now? Up here we have all of the vertices, and we could put in a list mask, which takes a list, our vertex locations, and then a list of Booleans, and the output here is just those vertices where the according Boolean is true. So that's perfect for what we need. All we really need to do here is output a Boolean list and plug this in here, and we're done. Our subprogram creates a Boolean list, and we can now mask all vertex locations with that Boolean list, which are just the ones closer to the plane. Now let's visualize this. Let me just create an icosphere in here. Maybe move it to the side. Go to edit mode, scale it down to something small, maybe even smaller. Okay, I'm also gonna give this icosphere an emission material right away. Maybe set to 20 and making it like this color. So we have a glowy dot and then we just create an object instancer of that icosphere. How many instances do we want? Well, exactly this many. And where do we want them? Object transform output. Transform these to a new location, and the location is exactly our masked list. And here we have it. These are the dots on the surface of the monkey that are close to this plane. Now we can't see the monkey because I hid this one here. Up like that. Okay. So we have the high poly monkey with the subdiv on it visible, and the not visible one is the one that we're using in here just to get the location of the vertices. Now if I hit play so that this gets executed every time the frame changes, which is this setting over here, frame change, and now I can GC, and you can see we're filtering out the vertices on the monkey's surface that are close to the plane. The distance is set here. So if I set this distance down, we get less because less are within the range. Or if I set it up, then we get more. GC. Okay. Also, if I rotate the plane, you can see this is the effect that we get. Okay, so that's basically the first part done. I'm going to take that down again, maybe even more. So we just get one line of glowy dots. Now we want those laser beams coming out of those glowy dots. How do we do that? Laser beams are going to be splines. So let's look at spline. We can create a spline from points, set it to poly because they're just going to be straight lines. And then we need a list of points. Okay, so within this loop, we're going to have to create a list of points for the laser beams. Each laser beam just needs 2 points. The first point is exactly where the glowy dot is. So where the vertex location is. The second spot, I'm going to make pointing outwards on the vertex normal. So the normals are vectors pointing out from the surface, and we get that information from the mesh. And we need the vertex normals in our loop to do that. So I'm going to have to get a mesh info node, take the mesh, plug it in here. Now the vertex locations here is the same as this vertex locations. I can also take this for my vertex locations and for here. And then here I have the vertex normals. I want to plug that into my subprogram. So I need a new input here, iterator, which is another vector list. Let's call that normals and plug the vertex normals in here. Another way to do this, actually we don't even need this mesh info node, is this node here. When we select it and we hit N to make this menu pop up here, the properties, you can see that this node has all these outputs and they're not enabled. So I could just go in here, enable vertex normals, and now this node has the vertex normal output, which is the same as this one. So to keep it simple, let's just take this and the vertex locations, and then we don't need that info node. So in animation nodes, sometimes you just have to look in the node settings over here, because sometimes nodes have more inputs and outputs than are shown by default, which can sometimes just make things a little bit easier. Okay, now we have a list of vertex normals. We put them into our loop. So here for each vertex, we also have a normal vector. The normal vector is just an x, y, and z of the normal, but a vector doesn't have a start and an end. It only ever has basically the end, just an x, y, and z, and it always starts at 0, 0, 0. So really the normal vector for this dot, for example, should start at this dot. So an easy way to do that is to just take a vector math node and add the starting point to the normal. And now we get a location here. I can probably even put in a 3D viewer. Make this show up somewhere. Now I don't know which vertex this is now, but just to show you the idea, this end of this vector here is now outside of the monkey head on the normal of whichever vector this is now. So we have this vector. Now we need a vertex list to create a spline. Okay, so we create a list, create vector list with just 2 inputs. The laser beam has two points in 3D space, the vertex and then the end of the normal, basically. So the vertex and the end of our laser beam is this. Now we have a list of 2 and we create a spline from that, create from points. Oh, I already have that node here. Let's use that. Plug that in here. So that gives us spline information. And in order to plug that, all of those laser beams into a single output, I'm just going to create a new generator output, spline list. Okay, so now our subprogram gives us a list of splines, and outside of the loop we can go to spline object output, create a new object, which is now called target, plug our splines in here, enable this button, and we have a whole bunch of normals basically showing up. And that is because we need to duplicate our mask list. We only want the splines that are close to the plane. And we take those. Okay, so now each of those little glowy dots has a laser beam coming out. Now we can select the target object, go into the curve settings, geometry, and actually give it some bevel depth. And of course, some sort of laser material, emission shader, bluish, strength 5. Okay, save the file. Now if I hit spacebar to play and GZ, now you can see we not only get glowy dots near our plane, we also get the laser beams pointing out. Okay, so this is the first effect that we can do with this setup. So if I rotate the plane, we get these crazy normal laser beams shooting out. Okay, what if we Alt G and R our plane here to set it back to this? What if we want the laser beams to come out on the normal but stay, you know, horizontally? So if we look at it from the top, we want them shooting out in all sorts of directions, but looking at the front, we just want them to be in a single plane. Well, that's very easy to do as well. This is the end point of our laser beam, the calculated point coming from our normal. Let's just take a vector separate. Let's separate this vector into its x, y, and z components. Then also take a vector combine. Take the x and the y, right? X and y. But not the c. We want the c to come from actually exactly the same height that the little dot is, so where the vertex is. So just duplicate the separate vector, take the vertex and take the c from that. Okay, so we have this setup. We take the x and the y from the end of our normal, and we take the c from the vertex location. Now we use this vector for the end of our laser beam, and now they're all shooting straight out at the same height where the vertex is, where the glowy dot is. So now we have this effect. Spacebar, G, C. So it looks like this now. Okay, that gives us the second effect with the laser beams all on a single plane. Now, one thing though, if I rotate this plane like so, you notice we get the dots that are close to the plane, but the laser beams are shooting out always horizontally. Maybe we want them to be on this plane, which is that effect of the one rendering there that I did, the body scanner effect. So how do we achieve that? Well, basically the same way that we did with finding the close points. We have to project the end of our laser beam onto this plane so that it sticks basically to the plane. And then the laser beams are going to be shooting out from the vertex and onto a point on this plane. Okay, so we take the project point on plane. The plane is actually the same plane that we're already using. this plane here. The point now that we want to project is the end of our normal, so this one here. Okay, so let's project this, maybe put that up here. And then use that projection for the end of the laser beam. And here we go. So now when I rotate this plane, we get the laser beam shooting out from the vertex and in the direction or staying on the surface of the plane. That gives us this body scanner effect. Okay, cool. So that's the third effect we can do with this not very complicated setup. And now all you really have to do is animate the camera, maybe animate this plane, so that you get this sort of like body scanner effect. And of course you can play with materials. For the body scanner rendering, I just gave this plane its own material. And also you can give the laser beams a different material so that they fade out, maybe. Also, of course, you could go and create a second plane, maybe have two planes moving somehow, and then do this for a second plane. Oh, and one final thing that I want to show you here is now these laser beams, they all have basically the same length, which is fine, but we might want to make them shorter or longer, and we can do that very easily with another vector math node that we plug into this normal's output here. The normal vector is always of length 1. That's just how it is. That's how Blender gives it to us. So we can multiply, or we can set this to normalize, and then we have a length here, and we can set it to 0.5 to make them shorter, or to 3 to make them longer. Right, so we can play with the length here, make them go basically to infinity. One thing that I tried out was to actually put this inside of a cube with some volumetrics on it, with a volume absorption node to make them fade out into the distance, to make them really look like lasers. You can be creative with this now. You have a few parameters here, the length of the laser beam, the distance to the plane, of course, all the materials that you can play with, and then you can create some cool animations. And if you do, please post a link to your work so that I can check it out. I love to see what you can come up with. That's it. If you like this video, please smash the thumbs up and subscribe buttons. I really appreciate it. I have also tweaked the materials a bit more and put everything together nicely in a blend file you can download over on my Patreon page. Thanks for watching. See you soon. Chris P. out.